In this movie, we're going to have a look at data aggregation. To begin with, let's use our sample database and let's run a very simple select query on the customers table joined with an inner join to the orders table using the cust_id column in both tables. We could use any of the alternative syntax I've mentioned in the last movie. As we can see, there are a number of different orders being placed by each of the customers. If we wish to get some more useful information about the customers' spending habits with our company, our fictitious company, then we could try some data aggregation to get some more useful data. Let's say we wanted to know the sum total of the amount that each customer had spent with our company over all of their orders. We could select the surname, then we'd use a special keyword called sum, and in brackets we'd put the name of the column that we wanted to add up everything from. Then we'd say from customers. Let's say we make it a left join this time so that we can see those customers that haven't placed any orders at all either. Inner join orders using follows very much the same syntax. However, at the end we're going to put a group by, and this group by is something that we're going to use with all the data aggregation that we're learning about in this movie. We're going to group our results by the surname. Let's take a look at what results we get from this particular select query. As we can see, the customers have all been shown together with the total amounts that they've spent with the company so far. However, the customers haven't been placed in order. Now, when we go to add an order by clause to that select query, what is it we want to order by? It looks like we want to order by the column called sum open brackets total close brackets, which is a bit of a mouthful. So when we come to write our select query again to reflect that order, we can use a column alias simply by writing as after the column that we specify in the list of columns at the beginning of the select query. Then we'll give it a name. Let's call it grand total from customers left join again orders using group by surname order by grand total, and let's say we order it descending so that we get the top customer first. As we can see, Versace comes out on top, quite a substantial lead over Gupta and Bonnet. Now, this use of column aliases allows us to not only add order by clauses and other clauses that help us to manipulate our data that we're getting back from our select query by using the aliases rather than their more complex column names that they would have otherwise, but it also makes these columns more useful to the applications and front ends that we are going to write and allow us to access our MySQL databases, for instance from the web, or using an intranet, or using an application on a single machine. Let's say we want to find out which customer has placed the biggest order of all time. We could use, instead of the sum function, we could use the max function. This aggregate function allows us to find the biggest order that has been placed by a particular customer, and we're going to call the column that it results from this function biggest order. Otherwise We're going to use the same left join to make sure we include all customers, including the ones that haven't placed orders yet. And we're going to order by biggest order descending. As we can see, the results are rather different here. Although Gupta was beneath Versace in the grand total stakes, Gupta's single order, however, was bigger than any of the single orders that Versace has placed, and so Gupta comes out in the lead in terms of being a big spender on one occasion. We can also find out the average that each customer has placed in a single order over their time as customers of the company. Of course, we don't have too much data in our tables as yet, in our fictitious company, but we have enough so that we can see the general way that this average total works. AVG is the function name, and we put the column name in brackets after it, just like we did with max and sum. As we can see, Gupta and Versace have still taken up the same places, but the figures are rather different because Versace's orders clearly range from large to quite small. For some reason, the Bull and Dupont customers have been placed at the top of the list. This is to do with the column type that is output by the average function. Finally, let's take a look at the count function. And we could count the number of totals, but let's count the number of order IDs instead. What this does is it simply counts the number of orders that have been placed. It doesn't matter which field we use really in the orders table, but we're going to use the order ID just to show that this has nothing to do with the specific amounts of money. We're going to use a left join once again. Same syntax. We're going to group by surname and order by number of orders, once again descending. As we can see, we've now been able to get data about each of our customers and the number of orders that they've placed with our company. In our next movie, we're going to look at the syntax that we found in this particular chapter and do a little revision of each of the new syntax that you've learnt in this chapter.